Yes. Good morning. Welcome to our lesson today. So we have mathematics. So we'll be talking about mathematics today. So under the topic of fractions, so ensure that you're very set for the lesson. So I will start by explaining what a fraction is. And a fraction is a representation of a whole. Or in other words, you can say a fraction is part of a whole. So for example, if you have an orange, then this orange, you cut it into 4 pieces. And then you give out one of the pieces. So you give out one of the pieces. If you represent that as a fraction, then you'll have given out one out of the 4 pieces. Therefore, it gives you a quarter. So a fraction is part of a whole. So out of the 4 pieces, you gave out 1. So if we represent that, then we are going to have 1/4. So that is what a fraction is a representation or part of a whole. So out of the whole, you take part of it. And the best example I've given is here. So we can talk about fractions into 3 parts. We can look at fractions as 3. So types of fractions. We can look at the first type of fraction as a proper fraction. The first type of a fraction we can look at is proper fraction. Now, a proper fraction is a type of a fraction whereby the numerator is smaller than the denominator. The numerator is smaller than the denominator. That is a fraction we refer to as a proper fraction. Now, a numerator is usually the number that is up, whereas the denominator is a number that is down. Now, for an example of a proper fraction, we can have a half. A half is an example of a proper fraction whereby 1 is smaller than 2. Therefore, that is an example of a proper fraction. The other example of a fraction, so I've said an example of a proper fraction is a half. So the number that is up is called numerator, while the number that is down is called denominator. So with a proper fraction, the numerator is smaller than the denominator. That is what we call a proper fraction. So we can have number 2, our second type of fraction, and we can talk about improper fraction. Improper fraction. So an improper fraction is the opposite of a proper fraction. If a proper fraction, the numerator is smaller than the denominator, what do you think an improper fraction will be? It will be the reverse. So with an improper fraction, the numerator is larger than the denominator. And an example is 3/2. So 3 is the numerator, 2 is the denominator. So 3 is larger than 2. Therefore, this is what we call an improper fraction. And the last type of fraction that we can look at is called a mixed fraction. The third type of a fraction is called a mixed fraction. Now, a mixed fraction is a combination of a whole number and a fraction. When you have a combination of a whole number and a fraction, we get what we call a mixed fraction. And for example, when we have 1.5, 1.5, this is an example of a mixed fraction whereby 1 is the whole number here. So 1 is the whole number. And then a half, in this case, is the fraction. So for a mixed fraction, we must have a whole number and a fraction. And this fraction must be a proper fraction. So this is a mixed fraction. We have an example 1.5. So 1 is the whole number, a half is the fraction. So these are the three types of fractions that we have. So we have a proper fraction, we have an improper fraction, and then we have a mixed fraction. Those are the types of fraction. Then we can have equivalent fractions. So for example, let's look at equivalent fractions. Equivalent fractions. So something that is equivalent means something that is similar to. To get an equivalent fraction, the number that you multiply in the numerator should be the same number that you multiply in the denominator. For example, if we have 2/3 as our fraction, our first equivalent fraction will multiply by 2/2. So multiply by 2 on the numerator and multiply by 2 on the denominator. So our first equivalent fraction, 2 times 2, that is 4, 3 times 2, that is 6. So our first equivalent fraction is 4/6. So that is an equivalent fraction to 2/3. Another equivalent fraction, you'll take 2/3 times 3/3. So the number that you multiply on the numerator should be the same number that you multiply on the denominator. So 2 times 3 is 6, 3 times 3 is 9. So 6/9 is another equivalent fraction. So let's look at the last equivalent fraction of 2/3. So we have 2/3, you can multiply by 4/4. So these are equivalent fractions. So 2 times 4 is 8, and 3 times 4 is 12. So 8/12 is an equivalent fraction of 2/3. So we can have as many equivalent fractions as possible. So you can go on and on. This is multiplied by 2/2. This is 3/3, 4/4. You can keep on multiplying 5/5, 6/6, 7/7. All those will give you what you call equivalent fractions. So that is how we get an equivalent fraction. So you can be tackling a question in an exam and you're given a fraction and you're asked, which one of the following fraction is equivalent to the one given? So to find an equivalent fraction, we multiply with the same number both on the numerator and on the denominator. So these are still the preliminaries of fractions before we go to working out of fractions. So I'm reminding you of the basics things that you need to know. So the other thing about fractions we can look at is simplifying fractions. Simplification of fractions. So simplification of fractions, you can have a fraction that is large. Then you are told to simplify. So it is the opposite of this. So this one, we are multiplying by numbers as we get large figures. Whereas when we come to simplification, we are trying to divide the fraction to get small figures. For example, if you have a fraction like 18/20, then you are told to simplify this fraction. You look for a number that can divide both the numerator and the denominator. That number that can divide the numerator and the denominator, you divide it by the numerator to get your answer and also by the denominator to get your answer. Now, like in this case, we have 18 and we have 20. So one of the numbers that can divide 18 and 20 without a remainder is 2. So to simplify this, take 18 divided by 2. 18 divided by 2 is 9. 20 divided by 2 is 10. Therefore, your answer here is 9/10. So you have simplified 18/20 into 9/10. We cannot simplify this number any further. Therefore, our right answer is 9/10 when we simplify this answer. Then it means when you work out fractions, always give your answer in a simplified form. If you work out your answer, for instance, and you get your answer as 18/10, it is not good to leave it as that. Make sure that you simplify that fraction. So we can have another example of an equivalent fraction. We can have another example of an equivalent fraction. We can have 14 over 36. That's another example of an equivalent fraction. Still, we look for a number that can divide this. So we still have 2. 2 divides 14 7 times. 2 divides 36 18 times. So your answer is 7 over 18. So these are examples of simplification of fractions. So when we do this, we are simplifying our fractions. And I've said, and I'll repeat, when you work out your calculations involving fractions, the answer you give, make sure you give an answer in a simplified form. Make sure you give your answer in a simplified form. So these are the preliminaries on fractions. So we want to look at working out of fractions now. And working out of fractions, we are starting with addition. We start with addition of fractions. Addition of fractions. So we look at addition of fractions. How can we add fractions? So addition, we are looking at the first form of a simplified fraction, whereby we look at a fraction that has the same denominator. When we are adding fractions that have same denominators, what are we supposed to do? Example. So the first example, we are looking at fractions with the same denominator. I started by telling you numerator is the number that is up and denominator is the number that is down. To remember that, know that down starts with D. So denominator is the number that is down. That will make you be able to remember easily. So an example of this, I can have 1 over 5 plus 2 over 5. When you look at my example, you realize that the denominators are the same. So we have 5 and 5. When you are adding such a fraction, you only add the numerators, but the denominator remains to be the same. So to solve this question, we are going to take 1 plus 2, you get your answer as 3. And then 5, don't add the 5. So 1 plus 2, we get our answer as 3. 5 and 5, that remains to be 5. So and when you're given this, your answer is 3 over 5. So when we add fractions, and the fractions have the same denominators, we only add the numerator and retain the denominator. And an example is 1 over 5 plus 2 over 5 to get your answer as 3 over 5. So that is our first example. Our second example, we are looking at a fraction. We are adding fractions that have different denominators. For example, you can have a half plus 3 over 4. So we can have a half plus 3 over 4. When we look at this example of ours, we realize that the denominator of the first fraction is 2, whereas the denominator of the second fraction is 4. Now 2 and 4 are not the same. So when you are adding fractions that have different denominators, it brings in the aspect of LCM, lowest common multiple. So I'm assuming we all know how to work out the LCM of fractions when you are given different denominators, although we'll still do it. So usually when you have 2 and 4, if you have two denominators and the larger denominator can be divided by the smaller denominator, the LCM is always that of the larger denominator. Like 4 and 2. 2 can go into 4. Therefore, our denominator here should be 4. But let's work it out with the LCM so that we can be sure. So 2 and 4, we are working out LCM. So the first thing, you look for a number that can divide 2 and 4, which is 2. 2 will divide 2, 1. 2 will divide 4, 2 times. You come and look for another number that can also divide 1 and 2, which is 2. 2 will divide 1, 1, and 2, 1. So when you're working out LCM, make sure that the last numbers down here is 1 and 1. Then you multiply the numbers that are here. So 2 by 2 is 4. Therefore, our LCM here is 4. Now, the next thing, you take the denominator for the whole, divide by the denominator of the first fraction, then you multiply by the numerator. So 2 goes to 4, how many times? 2 times. 2 times 1 is 2. So you write it there. Then 2 goes into 4, 2 times. 2 times 1, that is 2, you write 2 there. 4 goes to 4, how many times? 4 goes to 4, 1 time. So 1 times 3, that is 3. 4 into 4, that is 1. So 1 times 3, that is 3. Then we add 2 and 3. 2 plus 3 is 5. So your answer is 5 over 4. Now you realize that this answer is an improper fraction. Remember, that is the first thing I explained. This is an improper fraction. We don't leave our answers as improper fractions. So in this case, what you're going to do, we are going to change this improper fraction into a mixed fraction. The answers we give, it should either be a proper fraction or a mixed fraction. We can't have an answer that is an improper fraction. So let's change that. Let's change that so that we can all see. So we change 5 over 4, which is an improper fraction, into a mixed fraction. So we divide the numerator by the denominator. So we divide the numerator by the denominator. So 4 divides 5 once, which give us 4. We subtract, we get 1. So when we write this as a mixed fraction, the number up here becomes the whole number. The remainder becomes the numerator. Then whatever we're dividing with becomes the denominator. Therefore, when you take a half plus 3/4, your answer is 1 whole number and a quarter. So this is how we work out when we are solving fractions that have different denominators. Remember, all these are proper fractions. Now, you can also have mixed fractions. So our third example now, on addition of fractions, we are adding fractions that are mixed fractions. And I said that a mixed fraction is a fraction that has both whole number and a fraction part. So an example to this, we can have 2.5. 2.5 plus 1 and a quarter. 2.5 plus 1 and a quarter. So this is a mixed fraction. 2 is the whole number, a half is the fraction part. 1 and a quarter, 1 is the whole number, a quarter is the fraction part of it. So when we are solving a mixed fraction, we first of all add the whole numbers separately, then we add the fraction part separately. So 2 plus 1, that is the whole number part, plus a half and a quarter. So we add the fractions like that. You take the whole number of the first fraction, which is 2. You take the whole number of the second fraction, which is 1. Then you add 2 plus 1. You get your answer as 3 whole number. Plus, you take a half, which is the fraction, which is the fraction part of the first. Then you take a quarter, the fraction part of the second. So a half plus a quarter, LCM of 2 and 4, we have already said is 4. So 2 into 4, that is 2 times. 2 times 1, that is 2. Plus 4 into 4, that is 1 times. So 1 times 1, you get 1. So it is 3 whole number plus 2 plus 1 is 3, 3 over 4. So you finish up by adding the whole number, you equate it to the fraction part. So which is 3 whole number, 3 over 4. That becomes your answer. When you take 2.5, you add to 1.25, we add the fractions and the whole number separately. So the whole number are 2 and 1, which are here. The fraction is 1/2 plus 1/4. So 2 plus 1 is 3, then 1/2 plus 1/4 is 3/4. Then you can now add the whole number and the fraction to get 3 over 4. Therefore, your answer to that question is 3 over 4. So this is what we do in fractions when we are adding the fractions. We have started by looking at addition of fractions with same denominator, different denominators, and whole numbers. So let's look at the next, which is subtraction. So that was addition. We are now looking at subtraction. Subtraction of fractions. So we'll start by looking at subtraction of fractions that have the same denominator. So example, that have the same denominator. For example, we can have 9 over 11, take away 7 over 11. When you look at our example here, you realize the denominators are the same. We have 11 and 11. Then the numerators are the ones that are different. In this case, you only subtract the numerator and retain the denominator. Therefore, 9 take away 7 is 2. And then the denominator remains to be 11. So 9 over 11 take away 7 over 11. Your answer is 2 over 11. So that is an example of subtraction of a fraction that have the same denominators. Let's look at our second example. We subtract fractions that have different denominators. For example, we can have 3 over 4 take away 1 over 3. 3 over 4 take away 1 over 3. So the first thing, or the first step, is to get the LCM, because you realize 4 and 3, these are different denominators. So we get the LCM of 4 and 3. So I'll work it out on the blackboard for all of us to see. I'll use this space here. So we are getting the LCM of 3 and 4. So we have 3 and 4. So we look for a number that can go to 3 and 4. So the first number we are using here prime numbers. We are using prime numbers. The numbers that we use here are prime numbers. So you start with the first prime number, which is 2. You look if 2 can go to either of these two numbers. So you realize 2 can go to 4. Therefore, you start with 2. So 2, if it can't go to 3, you just repeat that number there. So 2 into 3, that is 3. 2 into 4, that is 2. We come to the next. Still 2 can divide 2. So 2, you repeat that. Then 2 into 2, 1. So we want to look at a number that can divide 3 and 1. So the number that can divide 3 and 1 is 3. So 3 here, 1 and 1. So therefore your answer is 3 multiplied by 2 multiplied by 2. 3 times 2, that is 6. 6 times 2, that is 12. Therefore, the LCM of 3 and 4 is 12. So the LCM of 3 and 4 is 12. Don't take 4 directly and say 4 into 4, 1. 3 into 3, 1. That is wrong. So you use prime numbers and start with the smallest prime number. Starting from 2. If we don't have any number that 2 can divide, you go to 3, you go to 5, 7, in that order of prime numbers. So 4 goes to 12. How many times? 3. 3 times 3, that's 9. Take away 3 into 12, that is 4. 4 times 1, that is 4. Then we take away 9 minus 4. 9 minus 4, that is 5 over 12. Therefore, your answer in this case, 3 1/4 minus 1 1/3, your answer is 5/12. So that is your right answer. So remember, when we have different denominators, when the denominators are different, you get the LCM. And then you divide the LCM by each of the denominators as you multiply by the numerator. Then you solve and get your answer. So in this case, our answer is 5/12. So that is addition. So let's look at the other subtraction, which is subtraction of whole numbers and fractions to give us mixed fractions. So the third example is on subtraction of mixed numbers. Subtraction of mixed numbers. So the first example that I'm giving is here, 4 1/5. So example 3, 4 1/5. We are taking away 2 1/4. Take away 2 1/4. 4 1/5, take away 2 1/4. 4 1/5, let me make it darker. 4 1/5, take away 2 1/4. Now, when we were adding fractions that are mixed, we took the whole numbers and added separately, and took fractions and added separately. But when we come to subtraction, we are not going to subtract the whole numbers separately and the fractions separately. What you are going to do, we are going to change these mixed fractions into improper fractions. We already know what improper fractions are. So we first of all change this. So if you want to change a mixed fraction into an improper fraction, you multiply the denominator by the whole number. The answer you get, you add to the numerator. So you multiply and you add. So 4 times 5 is 20, plus 1 is 21. So we have 21/5. Take away, we multiply, and then we add. So multiply here and add there. So 2 times 4, that is 8, plus 1, that is 9. 9/4. Then we get the LCM of 5 and 4. We get the LCM of 5 and 4. So we can do it here, LCM of 5 and 4, so that we can work out that question, LCM of 5 and 4. So we have 4 and 5. We start with the first prime number, which is 2. 2 into 4, 2 times. 2 into 5, 5 times. We look at the next, which is 2. 2 into 2, 1. 2 into 5, 5. Then we come to 5. 5 into 1, 1. 5 into 5, 1. So our LCM is 5 times 2, which is 10. 10 times 2, which is 20. Therefore, our LCM here is 20. After doing that, you take 20 divided by 5, which is 4. Then 4 times 21. So 21 times 4 is 84. So 4 times 1, that is 4. 4 times 2, that is 8. So we have 84 here. Take away, 4 goes to 20 5 times. 4 into 20 5 times. 5 times 9, that is 45. 5 times 9, that is 45. So we solve 84 minus 45. So let me go step by step for everybody to follow. 84 minus 45. When you are subtracting, remember to borrow if it cannot subtract. So 4 minus 5 is not possible. So you borrow 1, you remain with 7, and that 1 you add it here. So 14 minus 5, that is 9. 14 minus 5, that is 9. 7 minus 4, that is 3. 7 minus 4, that is 3. So you get your answer as 39/20. 39/20. Remember, I said you are not supposed to leave your answer as an improper fraction. Therefore, we change that improper fraction into a mixed fraction. We are changing that improper fraction into a mixed fraction. So the improper fraction is 39 over 20. The improper fraction is 39 over 20. So we are changing 39 over 20 into a mixed fraction. So we divide 39 divided by 20. 20 goes to 39 one time. If you multiply by 2, that is 40. 39 is below 40. So 20 into 39, that is 1. So you get 20, subtract. This is 9, this is 1. So how do we write this as a mixed fraction? So we take that 1 to be the whole number, 19 to be the numerator, and 20 to be the denominator. Therefore, when you add this, when you subtract this, 4 and a fifth, take away 2 and a quarter, your answer is 119 over 20. That is on subtraction of fractions. So we have looked at subtraction of fractions that have the same denominator. We have also looked at subtraction of fractions that have different denominators. And we have also looked at subtraction of fractions that are mixed fraction. So that is on addition and subtraction. So we can look at the next thing. Which is multiplication. Multiplication. So let's look at multiplication of fractions. So remember, we are done with addition, we are done with subtraction, so we are looking at multiplication. And the first example that I'll give is multiplication of proper fractions. So we have examples. So the first example, multiplication of proper fractions. So we can have an example like 3 over 4. 3 over 4 times 5 over 6. We have an example, 3 over 4 plus times 5 over 6. 3 over 4 times 5 over 6. So when we are multiplying this fraction, we look at the numerators and denominators and simplify. Remember, we are simplifying a numerator and a denominator. We have already looked at simplification of fractions already. So we look at if there is any number that is divisible in the numerator and in the denominator, then we can simplify. So we have 3 and 4, which is not possible. 5 and 6, which is not possible. 5 and 4, which is not possible. 3 and 6, which is possible. So we simplify 3 over 6. So 3 divides 3 once. 3 divides 6 twice. So there is no any other fraction that we can simplify. You don't simplify denominator and denominator. Don't simplify 2, 1, 2, 2. That is wrong. Therefore, our answer, to get our answer, we take 1 times 5 to get 5. And then you take 4 times 2 to get 8. Therefore, your answer, when you multiply 3 and a quarter times 5 over 6, you get your answer as 5 over 8. That's what we do when we multiply proper fractions. Let's look at what happens when we are multiplying mixed fraction. Example can be 1 and a quarter. We are multiplying 1 and a quarter by 3 and a half. 1 and a quarter multiplied by 3 and a half. So we cannot multiply fractions when they are in whole number state. So the best thing that you need to do, you change these whole numbers into improper fractions. So 4 changed into improper fraction, that is 4 times 1, which is 4, plus 1 to get 5 over 4, times 2 times 3 is 6. 6 times 1, it is 6 over 2. That is that. So 4 times 1, 4 times 1, 4, plus 1, 5 over 4. 2 times 3, 6 plus 1, 7. 7 over 2. So we get that. 7 over 2. Corrections there. We get 7 over 2. Then we can be able to see if there's anything that we can simplify. So we have 5 and 4, which is not possible. 7 and 2, which is not possible. 7, 4, not possible. And 5, 2, not possible. Therefore, what we do, we multiply the numerators first. 5 times 7 to get 35. 5 times 7, 35. 4 times 2, 8. Then you change that 35 over 8 into a mixed fraction. 5 over 8 into a mixed fraction. 35 divided by 8. So 8 goes to 35 4 times to get 32. Subtract 5 minus 2 is 3. So therefore your answer is 4, 3 over 8. When you multiply, your answer is 4, 3 over 8. So that is what we do when you're multiplying the fractions. So we are left with the last bit of fractions, which is division of fractions. So we are left with division of fractions as our last part. So division of fractions. I will start with one that has a proper fraction. So we have example, division of proper fraction. So we can have 2/3 divided by 8 over 9. 2/3 divided by 8 over 9. When you are dividing fractions, remember there are two things that will happen. When you divide fractions, there are two things that will happen. One of the things that will happen, we are going to change the division sign into multiplication sign, and then we get the reciprocal of the second fraction. So we change division sign to multiplication sign, and then we get the reciprocal. So we have 2/3 multiplied by, this one has changed, 9 over 8. Then we see if there's something we can simplify. So 2, 1, 2, 4. 3, 1, 3, 3. Therefore, our answer in this case is 1 times 3 to get 3. 1 times 4 to get 4. So your answer is 3 over 4. So this is what happens when you are multiplying fractions. The other bit of the fraction is when you have a mixed fraction. I will just explain that because of time factor. So when you divide mixed fractions, first of all you change them into improper fractions, and then you do exactly what you've done. You change the division sign to multiplication sign, and then you get the reciprocal of the second fraction. So I want to conclude the lesson. That marks the end of our lesson today. I've been your teacher, Teacher Stapleton. Have a wonderful day ahead.
Pastry is a stiff dough made from flour, water, or any